welcome in peace. My name is Sean. I'd like to thank everybody for tuning into this episode of Science with Sean. We're back with part two, 26 minutes left to go on our bill. Before we get going, please like the show, share the show, let everybody know that we're live. I appreciate people that have popped up in the chat currently. Priest Brother Mathis, and to all the onlookers who may comment or may not even comment, but just here to actually learn. So before we get going, I just want to give everybody an update based on data from epidemiologists. We are currently averaging about 70,000 new cases a day from COVID. Now, that case number, right, is still high. It's very much so high. However, it's down from the 80,000 that it was a few weeks ago. And deaths are down 300. So instead of the deaths being at 300, which a little over a month ago, the death rate was 2,000 deaths a day. And then it slowly went down, and then it got to about 1,500. Now somewhere between 12 and 1,500 deaths a day, more so on the 1,200 deaths a day side. Things are turning around. So we think. And I say so do we think because right now in the UK, they are seeing an uptick in new COVID cases, and deaths have increased. So they've seen a rise in new infections and deaths increase. So what that says to the United States is, if we don't have things under control, we have the potential of having another surge, and then the numbers could spike up, and we could see the deaths climb back up. We could see the number of infections go back up, and then what's left out there would be the continuum of the pandemic. We wouldn't officially turn the corner to an endemic phase until we got those under control. But 70 to 75,000 new COVID cases is still way too high. If we're trying to round it out, we need to be way below that. And we still have 30 million people that are unvaccinated in the US. Fully vaccinated, I should say. So those are some of the things that I just wanted to start off the show with real quick. I do want to get into just a little bit more of scientific integrity for the people. And then we'll get in, since we only got 26 minutes of our video left, we'll get into the last 26 minutes and we'll follow up with our video. So again, in regards to scientific integrity, we have now moved on to scientific method. And as Francis McCreany states in the book, it says, textbooks teach us that scientific research proceeds according to the scientific method. I'm going to say that again. Textbooks teach us that scientific research proceeds according to the scientific method. In the following, such a systemically amplified scientific method, a gap in knowledge is identified and questions are posed. Existing information is studied, and a hypothesis, a prediction, or educated guess is formed to explain certain facts. Information is gathered and analyzed and interpreted in the process of testing the hypothesis. I'm going to say it again. So information is gathered, analyzed, and interpreted in the process of testing the hypothesis. Results may support or refute a hypothesis, but a hypothesis cannot be proved. Indeed, a hypothesis can only be disproved. Further testing of specific hypotheses and their derivatives strengthens their support and leads to the genesis of theory. Now, theories take into account a strongly supported hypothesis or a set of hypotheses and encompasses a broadly accepted understanding of natural concepts. Remember, the study of science is the study of the natural world. I'm saying a little wrong for y'all, but when it comes to science, when you're trying to define science, it's best to be described as something that is, you're looking to answer questions regarding the natural world. If it's outside of the natural world, then it's unscientific because you can't prove something outside of that. So we have to make sure that we keep into the account what science is. Science answers questions. All right. So when hypotheses are not supported, the results obtained to reach this conclusion are often used to refine and construct other hypotheses, and the process begins anew. So this is important in the scientific method. Remember, we spend a lot of time arguing with people who have formulated a hypothesis and argue it as if it's a theory. So the arguments become circular because they don't have a way to test their hypothesis. For instance, and I'm going to give you an example, right? I'm going to give you an example. This is a good one. So 5G is spreading the coronavirus. I'm going to say that again. 5G is spreading the coronavirus. We believe that this new technology called 5G is spreading the coronavirus because we didn't have a new virus until the emergence of 5G. So how do you test the hypothesis, right? Well, first things first is, can technology spread a virus? So you have to understand what SARS-CoV-2 is, and then can it be spread through 5th or 5th generation technology? Hopefully I'm not losing anyone. But these are the arguments that we had earlier on in the pandemic because this was an initial claim created by a specific human being who she made it famous. And she ended up making a lot of money off of just claims like that. However, to test that, right, it's going to take a lot. So what tools can you use to test? You're going to need towers. All right. Now you have radio transmitting towers, right? You got these towers, these satellites that project out and help speed up things, transmitting and all of that. So you got to know a whole lot about these towers and the specifics of that. All right, cool. I get that. But now you got to show me how to get a virus inside of this communicative wave and then have it be transmitted to people. Mind you, these towers that they've put places to transmit and to help with technology and all of that are very high in the air. So those radio waves would have to drop down to a level where they can affect us. Y'all ain't feeling me? But this is a hypothesis. So the person that created this this hypothesis never explained how technology could spread a virus. See, it's falsifiable once you break down the claim in its entirety. But yet we spent months refuting this claim on several different channels and several different fronts. And the whole time, people that were regurgitating the claim never slowed it down to understand what 5G was and what a damn virus is. Once you understand what 5G or fifth generation technology is, and once you understand what viruses are, you immediately come to a honest conclusion that refutes the narrative at the gate. But let's continue. So, a hypothesis that has been unequivocally rejected on the basis of interpretation of experimental evidence can provide the inspiration for a new hypothesis, which may survive the test of repeated attempts to reject it. The value of hypothesis resides in its ability to stimulate additional thinking and further research, rather than in its initial correctness. Now, Bayer has written about what he terms the myth of scientific method. He contends that scientific research rarely proceeds by the organized, systematic approach that is reflected in textbook presentations. Approaches to be solving problems and answering questions involve various blends of empiricism and theorizing. Depending on the scientific discipline and on the intellect and personality of the scientist, research is conducted with considerable variations of the scientific method. Bayer argues that the science varies immensely in its characteristics, and he proposes two categories: textbook science and frontier science. Textbook science has withstood the scrutiny of time and is not likely to be subject to frequent change. Frontier science is often termed cutting edge science. It is volatile, sometimes unreliable, and subjective to considerable change. Bayer correctly points out that the textbook science fails to reveal the true working of scientific exploration because it teaches us only about successful science. Hence, it is not an accurate portrayal of the often covalent pathway that leads to accepted and relatively stable scientific results. Such end products of research are commonly the results of several experimental pursuits that use different lines of intellectual thought and technology approaches. Such efforts can occur over long periods of time, during which corroborative or contradictory evidence must be addressed and, where necessary, reconciled. Textbook science evolves to a point of general acceptance with the caveat that future knowledge may further refine, modify, or even disprove it. To attempt to explain this process as a result of the systemic implementation of a single prescribed scientific method sheds light on the way science actually works. Bayer's concepts of frontier science is relevant to scientific integrity. Frontier science invites close examination. Methods, data, interpretation, and conclusions are scrutinized as part of the process. Issues like honest error and differences in judgment emerge. Unfortunately, the rigorous analysis of frontier science can lead to erroneous perceptions of misunderstanding that can translate to accusations of scientific misconduct. Now, scientists' intuition and their judgments and decisions may be subjected to scrutiny in ways that can take on air of investigation. Who's to say that a scientist's intuition about a problem constitutes bad judgment or sloppy science, as opposed to deliberate deception? Deciding to discount eczema or enzyme assay data that were obtained from protein preparations extracted from the biochemist might call unhealthy cells serves as a hypothetical case in point. Now, can intuition be relied upon or recognize potentially flawed data? Such are the gray areas of the science both its practitioners and its critics must address. Clearly, scientific intuition can be applied to a problem in a way that allows the investigator to make a major conceptual advance. All right, so here we have it. Bayer arguing against one way or another, allowing certain things to come into play here. But it is rational to conclude that there is no single scientific method. All right, scientists use many different strategies and methods in their exploration of nature. Rarely, if at all, is this process orderly, even though scientific publications present information in a way that suggests a logical and ordered progression of research. Bayer submits that we should view the class descriptions of scientific method as an ideal rather than a specific formula for performing research. He further suggests that the projection of the concept of prescribed scientific method provides society with unrealistic expectations of science and scientists. Last, let us remember that the practice of any form of scientific method is far from the objective behavior that forms the stereotypical image of research. The objectivity of science that the naive onlooker assumes to be integral of the process begins to evaporate quickly at the stage of formulating the hypothesis. This is, again, where people are stuck arguing and hypothesis. The formation of hypotheses will be affected by the knowledge, opinions, biases, and resources of the investigator. Furthermore, hypotheses are subject to experimental testing by means of technologies and observational methods selected by the scientists. The decision to test a hypothesis means a commitment of time, energy, and money. In the past, these decisions were usually made by an individual, but an increasing complexity of collaborative nature of scientific research, especially biomedical research, frequently mean that these decisions are made collectively. In either event, the process is profoundly human in nature, and both gut feeling and intellect are used in making decisions. To close, thus defining a universal scientific method with which to measure the integrity of the research process is neither practical nor logical. Now, Howard Schachman's blunt assessment of the persecution of scientific misconduct carries this message. He says, it is inappropriate, wasteful, and likely to be destructive to science for the government agencies to delve into the styles of scientists and their behavior patterns. Gusting further argues that the codification of methods for defining, monitoring, and prosecuting scientific misconduct is dangerous because it assumes there's a single set of practices commonly accepted by scientific community, and it sets up a government agency to root out the deviations from these practices. Can't define universal scientific method. There's no universal scientific method. So, when it comes to the scientific method, it is designed to help scrutinize and falsify the things which people hold to be true. From the example that I used earlier regarding 5G technology spreading SARS-CoV-2. Just in that analogy alone, what we've come to find out here is something of importance, right? That something of importance is, first of all, how the hell can a fifth generation, or how the hell could technology transmit a virus, right? How, I'm gonna ask again, how can technology transmit a virus, a pathogen, a novel one? It's never been seen before. What are you using? Okay, so in this technology, it is radio waves, right? Radio waves. This thing is about transmitting signals. This is waves. So if we know it's waves, how could a wave transmit a virus? That's the claim that we're dealing with right now, right? We're showing how hypotheses work, right? It's an educated guess. So here we go. I'm gonna guess that 5G can help a virus travel from one place to another, untapped, unbothered, unscathed, to transmit the disease we know as COVID-19, to infect people. So a radio wave is now going to infect you with a pathogen you've never seen before, right? And cause all the damage. See, this is why thinking critically and being able to analyze data and um, checking checking your references and scrutinizing the claim and knowing your author and all of these things. This is why those things are prevalent and relevant to us today, because it helps us do this: answer the question, falsify it. Falsify whatever information that we have in regard to that, and just move on. We ain't even got to do a whole lot of anything. We just move on with our proper understanding of what of viruses allows us to immediately dismiss the 5G stuff. Hands down. See, we got some people in the building, man. Like the show, share the show. Come on in, have a seat, pull up a chair, get your pen, get your pad, hit the like button, show the channel some love, subscribe to the channel. We can take another claim. What's another claim? Oh, the other claim is is the vaccine will alter your DNA, right? So I believe that the vaccine will alter your DNA because it has to be injected into the body, which is going to affect the cells and which will play a role on your DNA, making it falter or some crazy stuff like that. So that's your hypothesis. Now we have to test the hypothesis, right? So in order for us to test it, we can use whatever. We can use a non-human primate. We can use monkeys, ferrets, whatever we want to use, humans, whatever we want to use. But for instance, let's just say we're going to use a non-human primate, right? Closest thing to humans. So when we do that, we inject the non-human primate with the vaccine, and we monitor where the vaccine travels. Now, remember, with mRNA technology, the 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 vaccine never goes to the nucleus of the cell where the DNA is. However, second generation vaccines do, like Johnson and Johnson. So now we've injected a non-human primate. We know exactly where this goes. We know how it deals with the whole the whole your body, the cell, the ribosomes, your memory, each one teach one, passing that along, training your immune system to recognize the spike protein, and then there you have it. So we look at the cells, right? Remember, you got so many different cells. So we can continue to monitor the cell to see if your DNA is being altered genetically. So now we're monitoring your DNA. We're extracting samples of your blood. We're looking at your skin, and we're looking for ways for your that this vaccine is altering your DNA. Nothing's happened yet. We've monitored for a while, but that's just This is how the scientific method works. Someone poses the question, they begin to test it, they look to falsify it. If it's falsifiable, they either trash it or they ask new questions and then they retest. Now, once it's been converted from a hypothesis to a theory, then the theory is tested over and over, and they're trying to falsify that data. If it's unfalsifiable over a course of time, and the test can be replicated over and over and over and over, it now becomes a scientific law. So when we're looking at, and I'm gonna continue to say this, people who make claims that 5G causes the spread of the coronavirus, we can immediately dismiss that because we can't really be honest, really can't even waste our time worrying about it, because a virus, knowing what a virus is and how viruses work, eliminate all that. So, man, let's get into the bill today, man. I know I probably talked y'all to death, but I just wanted to get in some scientific integrity, let y'all know what I've been reading, what I've been on. You know what I'm saying? I like to reread what I've been dealing with already, because it helps. Uh, it helps me, help you, but it also helps me. It also helps me with retaining certain things, but just listening to how crazy some things are, and then how right some things are. So yesterday when we ended the video talking about immunological memory and a duration of time in the IgG plus, which pretty much was talking about the immune memory and the B, right? Because we knew that the T cell memory and the antibodies for naturally infected people, that stuff wavered over a period of time, and that period of time was that they were looking for measuring was between 6 to 8 months. And however, they realized that most people wasn't obtaining any type of immunity even prior to that. But the immunologist, Dr. Crotty, was actually kicking his stuff. So I just wanted to bring people up to speed. We're going to wrap up this last 21 minutes of the video. I thought it was 26, but it's 21. And then we should be good to go.
Where everything disappears, whatever they have at 6 months will be, slowly reducing over time. Okay, and here's a summary slide on that, which many studies have now come out in terms of directly observing rates of reinfection as opposed to directly measuring immune memory. And those studies have really corroborated what we found here, is that the majority of people are well protected from reinfection for a significant period of time, but also that there is significant heterogeneity in the population, and some people do experience reinfections. Okay, so I'm going to shift back to vaccines now for the end, the final section, and again thinking about the anatomy of this infection, and the fact that it's a race between your virus and the immune system. We now have amazing vaccines against these viruses, and they clearly make good antibody responses that are good at protecting for at least a period of months. And one of the big questions has been what happens over time, because I think in terms of the models that I was describing to you to show it in a different visualization, probably protection against any detectable infection, i.e. a positive PCR test. Antibodies are going to be major contributors, and T cells are going to be minor contributors. I think there's data that T cells can contribute, but antibodies are probably bigger. Whereas protection from more serious disease is probably, as I mentioned before, more of a mixture, and it can be accomplished by a variety of these, because of, again, the time gap, that if you have memory B cells and memory T cells, there's significant time for them to attack the virus and destroy it before it causes real problems in the long. And so trying to think about those over time, one of the big questions about the RNA vaccines has been they are new. And so while they were clearly generating a good antibody response early on, were they generating a good T cell response? And then also, did they generate good memory? Were there still responses 6 months out? And so this is a study that we published just last month trying to answer those questions. And here's a one-slide summary of it. Antibodies declined over 6 months, which has been reported by multiple groups, including the Moderna clinical trial. And what we were very pleased to see was that the RNA vaccine, even when given at a low dose, which is actually what we were studying in this case, makes very good T cell memory. And that
All right, so he's clearing the conceptions up, but there's also something that he's dealing with. He just said that mRNA vaccine, specifically speaking, the Moderna vaccine, at a lower dosage warns or has warning protection over 6 months. 6 months was the guideline of what they're looking for. However, if you're unfamiliar with science and how science works, there's scientific evidence where they looked at the mRNA vaccine and the memory after 1 year, and it still showed protection and antibodies and so on and so forth. It had every last one of these levels that he's about to get into. It was dealing with all of that. But we have to make sure that we understand what he's saying when he's saying what he's saying so that we don't get lost. All right.
more of a mixture it can be accomplished by a variety of these because of, again, the time gap, that if you have memory B cells and memory T cells, there's significant time for them to attack the virus and destroy it before it causes real problems in the long run. And so trying to think about those over time, one of the big questions about the RNA vaccines has been they are new. And so while they were clearly generating a good antibody response early on, were they generating a good T cell response? And then also, did they generate good memory? Were there still responses 6 months out? And so this is a study that we published just last month trying to answer those questions. And here's a one-slide summary of it. Antibodies declined over 6 months, which has been reported by multiple groups, including the Moderna clinical trial. And what we were very pleased to see was that the RNA vaccine, even when given at a low dose, which is actually what we were studying in this case, makes very good T cell memory, and that the CD4 T cells declined only about twofold over 6 months after the second immunization, which indicates you'll probably have T cell memory to these vaccines for, probably 10 years into the future at least some, low measurable amount. And there was.
You heard what he said. And no, he wasn't making it up. You heard what he said when it comes to T cell memory. Remember, people are looking at antibodies and how long you develop antibodies. They're using that as a measuring stick. Antibodies. Then they're looking at T cell. Then they go, of course, look at B cell. But let's get it in. Hey, he kicking that stuff right here. I'll keep going back because he kicking, like, y'all don't know, but he kicking that stuff. It might sound whack as hell, but he talking about how effective the vaccine is in real time based on studies that they did.
And so trying to think about those over time, one of the big questions about the RNA vaccines has been they are new. And so while they were clearly generating a good antibody response early on, were they generating a good T cell response? And then also, did they generate good memory? Were there still responses 6 months out? And so this is a study that we published just last month trying to answer those questions. And here's a one-slide summary of it. Antibodies declined over 6 months, which has been reported by multiple groups, including the Moderna clinical trial.
All right, he's knocking out antibodies. Now remember, he's referring to a low dosage, and he's comparing it. This is based on the clinical trials. Blah blah blah. So you have to keep that into account. Remember, Moderna gives you 50 UG. In your initial vaccine, 50 UG. Not 25, 50.
And what we were very pleased to see was that the RNA vaccine, even when given at a low dose, which is actually what we were studying in this case, makes very good T cell memory, and that the CD4 T cells decline only about twofold over 6 months after the second immunization, which indicates you'll probably have T cell memory to these vaccines for probably 10 years into the future at least some low measurable amount. And there was some confusion initially about CD8 T cell responses to the RNA vaccines. We and others have now shown that both the Pfizer and the Moderna vaccine do elicit CD8 T cell responses in a majority of individuals. And in those where it's measurable, similar to the CD4s, there is good T cell memory. And one of the ways of comparing it would be to compare it to people who had previous infection. And we asked, all right, how does the spike-specific memory in terms of antibody, CD4s, and CD8s look 6 months out with even a low-dose RNA vaccine? And they were actually equivalent. Then we asked, well, what about the full dose? So Moderna as a full dose is 100 micrograms. What's the dose range? And it's about twofold better, twofold more antibodies or CD4s if you have 100 micrograms compared to 25. So that's actually...
Remember, the full dose is 250 shots. Don't think they give you 100 each time. No. The first, they give you 50. The second, they give you 50. So the full dose is 100. 100. I hate that they got this. Let me see if I can get. Yeah, my bad. Sorry. But here you go. Let me run it back. And I don't know why I even been having to close. Oh, yeah, because dude was foreign. But let me run it back and let y'all get the full gist.
T cell responses to the RNA vaccines. We and others have now shown that both the Pfizer and the Moderna vaccine do elicit CD8 T cell responses in a majority of individuals. And in those where it's measurable, similar to the CD4s, there is good T cell memory. And one of the ways of comparing it would be to compare it to people who had previous infection. And we asked, all right, how does the spike-specific memory in terms of antibody, CD4s, and CD8s look 6 months out with even a low-dose RNA vaccine? And they were actually equivalent. Then we asked, well, what about the full dose? So Moderna as a full dose is 100 micrograms. What's the dose range? And it's about twofold better, twofold more antibodies or CD4s if you have 100 micrograms compared to 25. So that's actually a pretty nice dose response. You still get a good response at 25. And then really lastly, in terms of directly trying to understand immune memory to the vaccine, what about age, right? There's a big concern about do older people make a significant immune response for some of the reasons I described earlier for the T cells, right? And we were very pleased to see that older individuals made as good of CD4 and CD8 T cell responses as younger individuals. If anything, they made slightly stronger T cell responses, which is a very positive sign, indicating that with a good vaccine and giving people the opportunity of time to make a T cell response, they very much can make that T cell response if they're not in a race with the virus. And then I'll skip this pre-existing T cell part in the interest of time. But we did find that some people have cross-reactive T cells before they're vaccinated or before they're infected. And the data shown in this study shows really for the first time that those T cells, those memory T cells that are cross-reactive, probably from previous common cold coronavirus infections, are actually functional, because people who have them actually make better antibody responses and better T cell responses, which we think is very cool. But I'm mostly skipping today in the interest of time. The final thing that I wanted to comment on briefly, as it relates both to antibody responses and T cell responses and memory B cells, is variants. Variants are very much on everyone's mind. I really love this article in Scientific American. That did a great job of explaining that really your immune system has evolved to fight variants. Your immune system has evolved for a long time. Viral variants are not a new phenomenon. Your immune system has ways to deal with variants. And of course, you have to love any article that shows a virus exploding on the surface and being destroyed. And essentially, the biology here is this, okay?
Before you go any further, this is also a misconception that actually has been argued on many Facebook posts, especially if a conversation about the immune system and variants is on Anquest post, you will find misinformation galore on that post, because one of the main things that anti-vaxxers and Facebook uh, scientists do is that they argue that you're going to need boosters for each variant. So they think that the immune system can evolve in a way to fight these different variants based on the vaccination status. But remember, in mRNA technology, the mRNA technology is significant because it is spike specific, meaning that your body creates a synthetic spike, the immune system recognizes it after 14 days, that whole thing is going out and the protection is there now. So the whole spike elevates elevates the protection level. So yeah, these different variants, it could be a different variant, but that spike ain't, you know what I mean? It ain't doing too much. There would have to be a significant change in the spike or the RBD, receptor binding domain, that would throw you off. And this is why, right, when Delta emerged as the dominant variant in society, we still had protection. Hospitalizations and deaths were still lower, right? The vaccines were still fighting. Now, because people are, all these people are getting vaccinated now, right? Now that we have more people getting vaccinated, these people who are now getting vaccinated and or booster shots are now, ladies and gentlemen, they're getting a version of the vaccine that is uh, Delta specific. Let's be real. Delta specific. These booster shots, Delta specific. You can't hide that science. So the efficacy in Pfizer's vaccines will increase, and you'll have more protection against Delta. See what I'm saying? And the saying goes, if a new variant comes out, now I'm telling y'all, we don't have to do this for every variant. We don't. But of course, if another variant comes out to be more dominant, more infectious, and causes more issues, they'll have to go to a drawing board, and they'll have to see, does it still protect against hospitalizations and death at a higher clip as all the initial things were. And that's really, at the end of the day, that's how we get to what we got. I said things, but y'all pretty much know what I'm talking about. If you don't, then I can just say that, and then I can be more specific. But let's listen to the immunologist. Get his game on. And by the way, if you're a Lakers fan, they ain't doing too hot right now. They're down 7.
Okay, going back to these, that memory B cells and CD4 T cells and CD8 T cells have different ways of fighting variants. And for the memory B cells, I told you that they were like antibody factories with the lights turned off, right? That they turn back on if you get infected and they make more antibody. That's really half of their job. The other half of their job is that your memory B cells aren't all identical. I showed you that diagram of the germinal center. Well, part of that process of generating the memory B cells is that to actually generate a bunch of memory B cell variants. So your immune system actually generates immunological variants to fight viral variants, which are basically best guesses by your immune system encoded in the memory B cell antibodies about what a future viral variant might look like. And so if you get infected by such a variant, you already have at least some B cells that can recognize that variant. And indeed, that's proven to be true and can be observed in booster immunizations or in people who have what's called hybrid immunity, where they had infection and then vaccination, they actually make much broader neutralizing antibodies, and that's showing that those were encoded in the B cell memory already.
What did he say? People who've been infected and vaccinated have hybrid immunity. They be having the best protection. You hear that, Wujawu? You vaccinated yet?
And then in terms of fighting variants for T cell, coded in the memory B cell antibodies about what a future viral variant might look like. And so if you get infected by such a variant, you already have at least some B cells that can recognize that variant. And indeed, that's proven to be true and can be observed in booster immunizations or in people who have what's called hybrid immunity, where they had infection and then vaccination. They actually make much broader neutralizing antibodies, and that's showing that those were encoded in the B cell memory already. And then in terms of fighting variants for T cells, the way T cells fight variants is different than the way antibodies fight, because T cells can recognize any part of the virus. And this is what I was showing you before, right? Not just one particular epitope, or in the case of infection, not just a surface protein. And so the diversity of the T cell responses is the way of fighting variants. If the variant mutates one sequence, it doesn't really matter, because there are already so many other sequences being recognized by the T cells that the immune system is still entirely functional. And the fact that the T cells recognize the virus in a different way than the antibodies helps give your immune system multiple different mechanisms of action to battle variants. All right? And this was directly demonstrated, again, in work led by Alex Setti, that looking at different variants, the T cells recognize them quite well. All right, so I will end there. This was a lot of the work that I showed was work by my lab and Alex Setti's lab, and it was a collaboration with many different people. I just want to highlight that first paper was led by an amazing postdoc, Alba Gaffoni. The Moderna study that we did was led by Assistant Professor Daniela Weisskopf, and the immunological memory study was co-led by Assistant Professor Jennifer Dan, postdoc Alex Cato, and Jose Mateus, with great contributions by a whole bunch of other people. So I will stop there, Facundo.
Yeah, thank you very much, Shane, for a wonderful talk, and thank you very much for all the contributions you have done in understanding this virus during the pandemic. I remember speaking with you while you were in the lab in the middle of this, and so thank you for that. I got a couple of questions from students and a couple of questions that I would like to pose. I mean, one that came to me is, how do you profile T cells, Shane? I mean, are you able to recover most of the T cell subset from the blood? And are you using also lymph node biopsies or aspirates? I know you do this in other species, but if you can explain a little more about that.
Yeah, that's a fantastic question, and a bit that I just took out in the interest of time. So thanks for asking. I'll just go back to this, because I was trying to highlight, right, what that location matters. So almost all human immunology studies are measurements from blood, and blood's what's accessible. It's straightforward to obtain it, and we can find memory B cells, CD4 T cells, CD8 T cells, and antibodies in blood. But the shortcoming there is that your immune system has to actually protect you in the tissues that you're getting infected with, right, which you're highlighting, importantly, Facundo. And that, so a question is, are those cells and antibodies at those locations? And it's very hard to measure them at those locations and have access to those tissues. And so we actually have the first paper published on this topic just a couple weeks ago, led by the wonderful Donna Farber, where having access to tissues from organ donors, we could directly show that in people who had been previously infected with just average cases, not hospitalized or anything, so just sort of quote unquote normal COVID, not only do they have memory cells in the blood, they specifically have memory cells that sit in the lung and sit in local lymph nodes. And so there are cells that are specifically staying in that tissue, and they're called tissue resident memory cells. so that if you get infected again, you already have a more direct layer of protection in that tissue. And not shown in this diagram is that we also directly measured memory B cells sitting there in the lung, presumably so that if you did get infected, those cells would reactivate faster, right? And so you would already get quicker protection because you didn't have to recruit cells from more. With the vaccines, the expectation is the cells are just in the blood, and so they have to be recruited into these actual tissues before they can have functionality, which is going to result in something of a delay before you start getting that protection. And so it'll be great to see more people study those problems directly, but it is hard to access those tissues and get those direct measurements. For germinal centers, it's a different story where those actually occur directly in lymph nodes. And yeah, we helped advance the use of directly sampling lymph nodes with using a clinical technique of just using a very fine syringe, and then you just numb the skin like you do for, if you go to the dentist, you get some lidocaine on your skin, so on your tooth, you do the same thing with the skin above a lymph node, and you can put in a very small needle and take out a few of those cells, and we can actually tell if there's an active immune response in that lymph node to the vaccine or not. And there have been a couple of really beautiful preprints showing that these vaccines do generate these germinal center responses, which is a real positive sign for the quality of memory.
Yeah, and this has to do with a question from Edward, that is one of the students.
All right, so I wanted to make sure that he was able to get that last part of information out, because that was critical in the whole gist of things, how science works and how things transpire. But it goes back to show you basically now why I even talked about the scientific method, because in this two-day build, we basically allowed him to walk us through his methodology and how he came to his conclusion, where he tested to see what was he testing for, to see if, what type of protection do the vaccines provide, right? Whether it was for 6 or 8 months or whatever, it was there. He was measuring immunity. That's how things get done. And he was very honest in his endeavors. So there you have it. That's all about immunity. So I do want to, before I roll out, I do want to get into something from our local epidemiologist, and I'll pull that up. By the way, if you ain't got what SARS-CoV-2 taught me, man, you need to get your book right now, bro. If you ain't got what SARS-CoV-2 taught me, you need to get your book right now, bro. Ma'am, sir, all of you people that's watching, the link is in the description of the video. Get the book. Same tree, different branch. Find a book. Get the book. Cart it. Purchase it. Slide out, ride out. Anywho, so we vaccinated for far less. All right. Now, this is from the epidemiologist, Dr. Jelena, and she argues here that more than 300,000 kids aged 5 to 11 years old have been vaccinated with Pfizer COVID-19. The vaccine is safe and significant individual level benefit for kids, prevents infection, disease, death, prevents long COVID, and will keep kids in school. COVID-19 is the 8th leading cause of death for children of the ages of 5 to 11. The 8th leading cause of death, and over 8,500 5 to 11-year-olds have been hospitalized. 30% of the hospitalized kids have no underlying conditions. With new authorizations, COVID-19 is now vaccine preventable disease. COVID-19 is now a vaccine preventable disease, specifically for children between the ages of 5 to 11. Some vaccine skeptics don't find the individual level benefit convincing and say we're just vaccinating kids for population level benefit, like reducing transmission. But vaccinating for population level benefit is not new. It came to my attention that many people are unaware of this. For example, take rubella. Rubella, which is the R in the MMR vaccine, is caused by a virus that spreads in airborne droplets from coughing and sneezing. Rubella outbreaks are hard to contain because people are infectious 1 week before symptoms arise. It's also very contagious. The RO for rubella is 6 to 7. Now remember, the RO in this instant is the R naught, meaning one person can infect between 6 and 7 people, right? I just basically said what she says in the next sentence. In other words, each infected person will affect on average 6 to 7 other people. Symptoms of infection among children are mild, which few noticeable symptoms are red rash, sore throat, low-grade fever, mild pink eye discomfort. About 25 to 50% of the children will not experience any symptoms, but yet rubella is mandated for children in all 50 states. If children have mild disease, then why vaccinate? All right. So her argument continues. Population level benefit. Rubella is incredibly dangerous for pregnant people and their developing baby. A person infected with rubella during the 3 months of pregnancy has a 90% chance of a baby not surviving or developing a severe illness called congenital rubella syndrome, CRS. CRS can result in deafness, blindness, heart defects, and severe permanent brain damage. We learned most about the rubella during a massive outbreak in the 1960s. From 62 to 63, rubella epidemic broke out in Europe, which eventually spilled over into the United States. That is why I said that we got to watch Europe, because their increase in COVID deaths and hospitalizations and infections will have some type of effect on the United States, whether we like it or not. So from 64 to 65, an estimated 12 million cases were reported across the country, despite warnings about keeping infected children away from pregnant women. Nearly 50,000 pregnancies were impacted. This led to 11,000 fetuses miscarried, died in the womb, or aborted. 20,000 infected infants born alive, with the majority had severe illness. 2,100 of them died shortly after birth. 12,000 were deaf. 3,580 were blind, and 1,800 permanently disabled, mentally disabled. So shortly after the vaccine, the rubella vaccine entered clinical trials in 69. It was approved by the Europe and North America. 71, the rubella vaccine is combined with the measles and mumps vaccine for what we now know as the MMR. This is a good read. It's a good read because it beats up on the notion of what people were saying. You're just vaccinating to vaccinate. No, we're vaccinating to protect. We need to protect. So it's a good example right here of, and let me see if I can pull this up a little bit. Yeah, there you go. So y'all should be able to see this a little bit better in this chart right here. And this was created by the epidemiologist. So she deals with SARS-CoV-2 and rubella. She talks about the R naught status. Look at the R naught difference. The R naught difference from rubella to a SARS-CoV-2. Look at SARS-CoV-2, 5 to 10 people. One person can infect almost 10 people. Rubella, 6 to 7. Viral deaths year prior to vaccine, 17, all ages. 5 to 11-year-olds, 66, 5 to 11-year-olds. Now, viral symptoms: mild rash, sore throat, fever, mild to severe fever, loss of smell, Miss C. Remember, in children, it's Miss C, which is serious, hospitalization and death. Asymptomatic rate, look at the asymptomatic rate for COVID: 16 to 50%, 25 to 50% in rubella. The vaccine target population, all 50 states right now, universal vaccination. The benefit in is mild, and then in COVID it is moderate to huge. So what's the vaccines benefit population? Moderate in COVID, huge in rubella. Risk M M MMR, very, very rare, febrile seizures or low platelet count, temporary and fully resolved. You got very, very rare myocarditis, which is inflammation around the heart, mild, in 75% of kids, fully resolved within 32 days. The percentage needed for herd immunity, look at COVID. Over 90%, whereas 83 to 85% of rubella. I don't even think he subscribed to this particular channel. I really don't even care, long as they gave a reaction to the show. You know what I'm saying? Maybe one day we have 50, 60, 70, or 100 people in the chat. Maybe not. Who knows? But there you have it on that. I'm not going to elaborate too much on this. Get your kids vaccinated. Get your kids vaccinated. The vaccine works. Protection against the spread of infectious disease, hospitalization, and death is significant. The Lakers are down 2 with 8 minutes to go. You want to make sure that you're doing what you can do to protect your family. Get your kids vaccinated. So, man, I do appreciate everybody for tuning in. This build is about an hour long. I'm going to keep it bite-sized. Not going to run too many people off. You know what I'm saying? Get back to the get back. Thank you for tuning in. Shimon Hotep. Y'all already know what I'm about to do. However, I do need y'all to go get what SARS-CoV-2 taught me. And make sure that you go watch the last presentation this morning regarding the Aaron Rodgers debacle.